Hello again. In this video we're going to continue looking at 2019 Junior Certificate Higher Level Paper 1, and this is question number 6. So in this question we have the following problem. Poppy and Ella run a 5k race. The simplified graph below shows the time it took Ella to run d kilometers during the race. One of the points on the graph is marked A. Distance is on the horizontal axis, which is here, and it took Ella 26 minutes to run the whole 5k. So we can see that time is on the vertical axis, and this is the 26 minutes point here. Now, the first part of the question is to draw a graph on the diagram above to show the time it took Poppy to run d kilometers during the race for 0 through d to 5, and d belongs to the set of whole of integers. So let's take a look at this now. At point 0, both Poppy and Ella are at 0 distance. Then as the distance increases, the time increases. So for Poppy, the graph is in red. At distance equal to 1, her total time is equal to 5. So I'm looking for that point on the graph and putting the point on the graph. Same for second kilometer, this time is equal to 10. For the third kilometer, time is equal to 17. Fourth is equal to 24, and for fifth kilometer, time is equal to 30. Marked all the points on the graph, and I connected the points with a straight line. If you did that, you get the marks for the graph. Now, the next part of the question asks us to, using Ella's graph, fill in the 3 missing values in the table below. So it asks us to read out total time taken for Ella for a particular distance. So let's look at distance d equal to 2 kilometers for Ella, which is this graph. Her time is equal to 8 minutes. You can see 5, 6, 7, 8. So let's put 8 over here. Then for distance equal to 3 kilometers, her time is equal to 14 minutes. And finally, for 4 kilometers, her time is equal to 20 minutes. So that was 15 marks for this part of the question. Next, we need to show that Poppy's times in the table do not make a quadratic sequence. One way to find out whether a sequence is quadratic or not is to look at all the elements in the sequence. So in this case, we have 5, 10, 17, 24, and 30. And a test for whether a sequence is quadratic or not is to look at differences between different elements and then differences between those differences, which is known as the second difference. So let's take a look at that. 10 minus 5 is 5, 17 minus 10 is 7, 24 minus 17 is 7, and 30 minus 24 is 6. So then going into our second difference, we have 7 minus 5 is equal to 7 minus 7 is equal to 0, and 6 minus 7 is equal to minus 1. So this is our first difference, and this is our second difference. Now, it wasn't enough to calculate the second difference for this sequence. We had to make a statement that second difference is not constant, therefore not quadratic. So this is an answer for full marks. Moving on to part C, we know that it took Ella 26 minutes to run the 5 kilometers. We have to work out Ella's average speed for the race. Give your answer in kilometers per hour, correct to 2 decimal places. Okay, so we can either calculate her average speed in kilometers per minute and then multiply it by 60, or we can try to calculate what percentage of an hour is 26 minutes. So let's do this first. We know that there is 60 minutes in an hour. So to find what percentage we need to divide, what fraction we need to divide 26 by 60, and if you divide that, the result is 0.4333 hours. So that's the fraction of 1 hour that is in 26 minutes. So then to find the speed, we know that speed is equal to distance over time. Our distance is 5k and our time is 0.4333 hours. So if we do that calculation, we get the speed equal to 11.538. Now we need to give our answer in kilometers per hour correct to 2 decimal places, so we have to do rounding to the second decimal place. 8 is greater than 5, so we round up and we get 11.54, and we can add the unit for completion. So 11.54 kilometers per hour is the right answer. Now we have to tick the correct box to show what happened to LS speed after 2 kilometers, which is marked A on the graph. Tick one box only and justify our answer. So let's look back at the graph. In the graph, we know that it took Ella 8 minutes to run the first 2 kilometers. So her speed was 4 minutes per kilometer for first 2 kilometers. And then from the second to 5th kilometer, she took from 8 minutes to 26 minutes, which means that it took her 18 minutes to run the remaining 3 kilometers. If it took her 18 minutes to run 3 kilometers, she took 6 minutes per kilometer for the remaining 3 kilometers. So that means that LS speed decreased, and for justification we can tell that it took her 1 kilometers in 4 minutes for first 2, and then it took she did 1 kilometer in 6 minutes for last 3. So that's the correct justification. Now the last part of the question, we have another graph. We know that Kieran, who also did the race, drew a graph below to show the time it took him to run d kilometers during the race. The part of Kieran's graph marked C is a vertical line. Now, what does the part C tell us about Kieran's running at this stage of the race? Give as much detail as possible. So a good answer for this question would be to take a look at how does the distance change as time changes. So we can see that the distance in the race doesn't change as the time changes, which tells you that Kieran stopped. And a good answer for this question would be that Kieran stopped at 2 kilometers for 5 minutes. This is as much detail as possible for this question, and that would be a good answer. The last part of this question is the following. Brendan says that Kieran's graph does not, very important, does not show total time as a function of distance d. Give a reason why Brendan is correct. I want to remind you that function has one output for one input. So let's take a look at what this graph is a function. Our inputs are usually on the horizontal axis and our outputs are at the vertical axis. So for time equal to 2, for distance even, for distance equal to 2, we have the following outputs: 10, 11, 12, 13, 14, 15, and everything in between. So there's an infinite number of outputs for one input. And if that's the case, this is not a function. Another way of looking at it is to do what's known as a vertical line test. So if you look at a function and you put a vertical line test, you'll see that there are multiple points along that vertical line for a single input. And that also tells you that this graph is not a function. Very, very important thing to remember, and I noticed that a lot of people had a problem with this question. So it would be very useful to recognize this and remember what a function is and what a function is not. And that's it for this question. If you have, for this problem, if you have any questions, leave them in the comments. Click like and subscribe, and thanks for watching. See you again.